Okay, today we're going to talk about section 10.6. 10.6 is about secants and angles. Um, so let's start with the definition of a secant. A secant is a line that intersects a circle in exactly 2 points. So I'm going to underline two parts there. One, that it's got to be a line, and two, that it is in exactly 2 points. And we have a picture of a secant over here. You can see circle C with line AB intersecting my circle in exactly 2 points, being A and B. And then here I have an example of a circle, and I know that that's cut off a little bit right now. Sorry. And inside this circle we have an example of all the different types of lines, segments, or rays that we've talked about with circles. Here in green we have a secant, and you can see the small little arrows on the end here showing me that that is a line and that it keeps going. And the main reason I wanted to talk about this picture is to compare a secant to a chord, because they are very similar. The big difference is that a secant is a line that keeps going after it crosses through the circle at two different points. But a chord must be a line segment, so it has two actual endpoints here on my circle. Okay. And then we just have, just for a reminder here, we have a nice pink diameter. Again, has to be a segment that goes through the center and then has its endpoints on the circle. We talked about how a diameter is just a chord that goes through the center. A radius with one endpoint, which is a segment with one endpoint at the center, one endpoint on the circle. And then a tangent, which we talked about last time, which is a line, segment, or ray. It can be any of the three that touches the circle only once at this point of tangency here. And then also they do a nice job of reminding us here that a diameter or radius drawn to the point of tangency will create a perpendicular or a right angle with the diameter and the tangent line. Okay. Now we have Theorem 10.12 here. And Theorem 10.12 says if two secants intersect in the interior of a circle, then the measure of each angle formed is 1/2 the sum of the measure of the arcs intercepted by the angle and its vertical angle. So I can see here that I have two secants, and even these are actually chords, but they work the same as secants because I can imagine that they keep going. So my theorem says that if I want to find the measure of angle 3, the measure of angle 3 should equal 1/2 of the sum of the arc that angle 3 creates, which let's do a little bit of highlighting here. Angle 3 goes out here and out here, and it creates this arc here, which is 120 degrees. And we also need to talk about its vertical angle. So let's do a little more highlighting. The vertical angle is, of course, the other side of this x. So that angle goes up here and down here and creates this arc. So angle 3 should be equal to half of those two arcs. So the measure of angle 3 is equal to 1/2 of those two arcs, which the first arc is 120 and the second arc is 100. So it is half of the sum of the arc created by the angle I want and its vertical angle. So then we just solve this, and that's 1/2 of 220 when I simplify inside, and 1/2 of 220 is 110. And that's the measure of angle 3. And again, sorry about my handwriting, still getting used to this new system. But that's definition 10.15 and theorem 10.12. We're going to go on and do two more theorems. So let's take a peek at our next two theorems. Theorem 10.13 says if a secant and a tangent intersect at the point of tangency, then the measure of each angle formed is 1/2 of its intercepted arc. So again, you should hopefully notice that this has the same pattern of two of our special types of lines or segments intersecting, and then we have this 1/2 of something relationship going on. Okay. And I apologize for my picture here. Got a little messed up and I had to just quickly redraw it so it doesn't look perfect there. Sorry. And we had a little typo, but that's nothing you haven't seen before. So we have in this picture, we have circle A, and we know that the measure of angle DBC is 64 degrees. And we're supposed to find the measure of angle CBE, the measure of arc BC, and just the measure in degrees, not the length, and then the measure of arc CFB, where I know this is a major arc where I go the long way from C to B because they include this point F in here. So I know that I start at C, and before I get to B, I have to pass through F first. So I'll be going this long way. Now, to find the measure of angle CBE, I notice that CBE and CBD are supplementary. So the measure of angle CBE should equal 180 minus the measure of DBC, which is 64, and so that is 116. And I'm going to take just a second and fill in the information that we have so far. So I know that, and I'm going to do my best to fit it in here neatly. I know that angle DBC is 64 degrees. Very nice. And then we just figured out that CBE was 116 degrees. And now we need to find the measure of these two arcs. And this is where this theorem 10.13 comes in. It says if a secant and tangent intersect at the point of tangency, which we have here because they say that DE is tangent, and I can see that CB is a secant, and they intersect right here at the point of tangency. So if that happens, then the measure of each angle formed is 1/2 of the intercepted arc. So if the angle is half of the arc, then the arc should be 2 times the angle. So because this angle is 64, this arc should be equal to twice as much. So the measure of arc BC, put that curve over so I know it's an arc and not the line segment, should equal the measure of the angle, which was 64, times 2, which will give us 128 degrees, of course. So let's put that on our picture. So this arc up here is 128 degrees. Now the last part is to find the measure of arc CFB, and again, sorry about the typo there. Arc CFB I know is a major arc because I go from C to F and then to B. Now there's two ways that I could think about finding this angle, or this arc measure. One, I could use the angle 116 that I just found and then do exactly what we did with the 64 and the 128. Because my theorem says the angle should be half of the arc, then I know that the arc should be twice as much as the angle. So I could possibly say the measure of arc CFB, and again I put my arc on top of it. The measure of that arc should be equal to 116 times 2, which is 232 degrees. The other way we could possibly have thought about that is we know that all the way around the circle is 360 degrees, and we already have 128. So CFB just needs to be the leftovers. So we could have said, instead, this would equal 360 minus 128, which is again 232 degrees. And that's theorem 10.13. Now we have one more theorem, and this theorem gets 3 parts. And this is taken right from your book. It says if two secants, a secant and a tangent, or two tangents, so they have 3 options there, 2 secants, a secant and a tangent, and 2 tangents. If any of those combinations intersect in the exterior of a circle, then the measure of the angle formed is 1/2 the positive difference of the measure of the intercepted arcs. And they draw you 3 nice little pictures here. It says the measure of angle A is 1/2 of this arc DE minus the little one BC. It's got to be the big one minus the little one to get a positive answer. Or in here, this angle A is equal to 1/2 the big arc DC minus the little arc BC. And over here, angle A is equal to 1/2 the big arc BDC, because that's a major arc, so we need 3 points again, minus the little arc BC. So let's look at this real quick. And they get a little bit tricky on us here, making us find some missing pieces, because to find this angle, I need to know this little arc, the 34, and this one. So to find this, that's supposed to be a question mark, but wasn't very good. So again, what I'm looking for here is this arc here. Now what I can do to find that is I can add 106 plus 34. Sorry, I'm trying to go too fast here. Plus 160. Add those 3 up, and that is 300, leaving just 60 for here. So my arc X should equal 1/2 of 60 minus 34, which if you simplify that, you'll get 13. Now this next one, I do the same exact thing, except here they've made my equations maybe a little bit trickier. So I set up X, this exterior angle should equal 1/2 of the big arc, which is 10x, minus 40. Solve this. I'm going to distribute first, bring my x down, and so this is 5x minus 20. Subtract, and that's negative 4x equals negative 20. Divide, and x is equal to 5. Same thing here. But they've switched it around on me. Now I know the exterior angle, so I know that 30 is going to equal 1/2 of the big arc, which is x, minus the little arc. And here the little arc is a little bit tricky. The little arc, since I know that the big one is x and the whole thing is 360, this is going to be minus 360 minus x. And we've got to watch our signs a little bit here. I distribute my negative in, turn this into a plus, that into a minus, this into a plus, and 30 is equal to 1/2 times 2x minus 360.